Let's jump right into this explainer and completely demystify a concept that is going to absolutely revolutionize how you write Go. You know that feeling when your team is literally just copying and pasting the same boilerplate code over and over again? Yeah, we've all been there. Today, we're unpacking the template design pattern. It's a behavioral pattern that is foundational to writing clean, scalable, and truly professional Go code.
To really grasp why this pattern is such a game changer, let's paint a picture. Put yourself in the shoes of a software architect building a payment processing system. You've got debit cards, credit cards, UPI transfers, the whole shebang. Now, every single payment has to follow a strict 5-step pipeline. Authenticate the user, authorize the transaction, fetch the account details, process the specific payment logic, and finally, confirm it. Imagine the absolute nightmare of 5 different engineers writing the exact same 5-step payment pipeline from scratch, where literally only step 4, the processing logic, actually differs between them.
And here is where it really hurts. What happens when a critical security bug is found in step 1? Well, suddenly that bug requires 5 separate fixes across 5 different files written by 5 different people. You fix it in one place, but then, surprise, it mysteriously reappears somewhere else. Your system becomes incredibly brittle. But if you use a centralized template, you fix that bug exactly once, and that one single, elegant fix automatically propagates everywhere. That's exactly the problem the template pattern solves.
All right, moving to section 1, the baking recipe analogy.
Think of this pattern exactly like a baking recipe. The skeleton of the recipe is completely invariant, but the specific flavor? That's deferred to you. Let's say you're baking a pie. The crust preparation, the oven temperature, the baking time, those are totally fixed. The author of the recipe guarantees those steps are going to work. But the filling? That step is an open question. You can use apples, you can use cherries, chocolate, whatever you want. The baking process doesn't care. The structure is frozen, but the details vary.
And this brilliantly maps to a core visual framework, kind of like a strings.join call with 3 distinct boxes. Steps 1 and 3, let's call them first and third. Well, those are locked boxes. They are invariant. They execute exactly as written, no exceptions. Meanwhile, the middle step, say a custom message function, is an open box. The template essentially guarantees that the locked boxes run in the exact right order, wrapping safely and predictably around your custom open box logic.
Section 2. Building the core template. Let's look at the mechanics and Go. So, how do we actually build this? We start with an invariant skeleton struct. That holds our fixed algorithm, those locked boxes we just talked about. Then, for the deferred step, we define an interface. Since Go doesn't use traditional class inheritance like Java or C++, we do this entirely through composition. We just embed the interface into our struct, or pass it in as a dependency. The skeleton simply calls the interface methods when it reaches that open box phase. It's a remarkably clean architectural choice.
But here is the really cool part. Because Go has first-class functions, we can iterate on this. We can actually replace those heavy, rigid interfaces with simple, idiomatic functional closures. Think about it. If your deferred step is literally just a single action, creating a whole new struct type just to satisfy an interface, it's totally overkill. Instead, your template can just accept an anonymous function. Boom, your code base is suddenly much leaner and way more idiomatic.
And we can take it even a step further by using an adapter bridge. This lets us seamlessly connect our lightweight closures with those existing rigid interfaces. Sometimes you're stuck working with a legacy interface you can't change, right? But you still want that simple feel of passing a closure. By wrapping your functional closure in an adapter type that naturally satisfies the target interface, you get the absolute best of both worlds. It's a perfect example of composing patterns together.
Section 3, strategy versus template. Let's clear up the confusion.
The main takeaway here is about structural guarantees. Strategy delegates the entire algorithm. It gives you looser coupling. You want completely interchangeable, totally different ways of doing something? Use strategy. But template delegates only part of the algorithm. It freezes the workflow. If you're writing an HTTP lifecycle where it absolutely positively must go connect, then authorize, then request, then response, you need a template. Strategy simply can't provide those rigid structural guarantees.
Section 4. The standard library's secret.
Okay, what if I told you that you are already using the template pattern every single day? Seriously. I love sharing this specific detail because it takes this high-level theoretical architecture and bridges it directly to the code you're already writing. Go's very own sorts.Interface is a textbook template pattern. When you call a sort function in Go, the standard library handles all the heavy lifting, the complex shifting, the pivoting, whether it's quicksort or heap sort under the hood. That is the fixed template. The standard library provides the oven. The only thing deferred to you, the developer, is defining how to compare those elements using the less, lin, and swap methods. You just provide the flavor. It's proof that this isn't just academic, it's foundational to the language itself.
Finally, Section 5, the deployment cheat sheet.
So when should you actually deploy this? This pattern absolutely shines when you're building HTTP middleware pipelines, data processing pipelines, or retry wrappers. It's perfect for frameworks where you want users to hook into your system without exposing all the scary internal complexity. Think about database transactions. You always need to begin, execute some custom logic, and then safely commit or roll back, right? The template manages those transaction boundaries for you perfectly, so you can just focus entirely on writing your queries.
But be careful, watch out for the anti-pattern known as template creep. When should you not use this? Well, if you defer too many steps, you don't have a template anymore. You just have an interface. If every single step of your process is different, or if the overall skeleton needs to dynamically change, template is totally the wrong tool. And honestly, if it's just a simple one-step operation, don't over-engineer it. A template's only valuable when it's actively protecting a meaningful, invariant workflow.
I'll leave you with this final thought. Template is about trust. The library trusts you with one step, you trust the library with the rest. Does your current architecture foster this level of elegant trust between your core systems and your business logic? It's fundamentally a contract. You trust the base system to handle the unvarying mechanics flawlessly, and the system trusts you to drop in your domain expertise right in the middle. So take a look at your code bases today. Where can you replace 5 fragile, duplicate pipelines with one rock-solid, trusted template?